All right, so we are continuing through 6.10, and this section of 6.10 is talking about like solving right triangles. And when I say solving a right triangle, it means finding all angles, all sides, all everything. Okay, and so because we're solving right triangles, you should know this already, but your right triangle tools you're going to be using over and over again. Those two tools are going to be your Pythagorean theorem and your trig. And again, I'll use either of those tools depending on what they gave me. Pythagorean theorem in general is if I need sides and they gave me sides. Trig is more if I need angles or sides and they gave me angles and or sides. Okay. The last little tool that you are aware of, but I just need to remind you, is the triangle angle sum theorem, which basically says all the angles add up to 180 degrees. And so that'll help you as well. And so that's actually what I'm going to do first in this first problem right here is I'm going to find that other acute angle up here by using the fact that all three add up to 180. In actuality, I add up the two acute angles, the non-right angle, to be 90. So I know that this guy already is 48 degrees, and so I'm going to put that in there. And then I'm going to go after finding C and B since those are the sides that I'm missing, right? And so because I'm looking for sides and they only gave me one side, I can't use the Pythagorean theorem. So I'm going to go after using one of my trig functions. And because sine is my favorite and they gave me 42, I'm going to start with the sine of 42 degrees is opposite over hypotenuse. Remember, we're going with so, right? And then back over here, this is my opposite side. So I'm going to go with 8 over c. And we've solved enough of these that you guys know how to do this. So I'm going to multiply by c at the same time as multiply by c as divide by sine of 42 degrees. And then appropriate things will cancel, right? So the sine of 42 and the sine of 42 divide out to be 1. And so I'm left with c. This c divides out with this c. So I'm really just left with 8 over the sine of 42 degrees. And then I just plug in to find my answer. And so that's not what I wanted, but it was my Desmos. So here goes. Oh, there's lots of stuff in here. Clear all this stuff out. So then I'm going to do 8 divided by the sine of 42 degrees. And then I'm going to make sure that I'm in degree mode, which I am. So it's about 11.12. So C is about 12 units, whatever that unit is. So I'm going to go 12 units. And that actually makes sense to me. I like to make sure that my my actual triangle makes sense. Like that number can't be, I don't know, 1,000. That doesn't make sense to me. So the fact that it's 12, that's pretty good. Okay. And then from here, I could do two things. I could either use another trig function to find b, or I can use the Pythagorean theorem to find b. Now, if you are going to be an engineer, then I would use the trig function based on the information that they gave me, not the information that I found. So if you use the Pythagorean theorem, 12 is an approximate, right? I got 12 from rounding 11.955812399. So if you're an engineer, you don't want to keep hitting enter onto your calculator because that's just going to make your error bigger and bigger. So your practice is going to be using the information that they gave you as opposed to information that you yourself calculated. Plus, then if you made some weird calculation error to find C, then it won't affect you finding B. So I'm trying to think of what trig ratio involves the opposite, well, not the opposite, sorry, the opposite and the B side, which I don't know, which is called my adjacent side, right? Because he's next to my angle 42. So if you think about who is that, and so I know it's not so. Here's ka and here's toa. Who has opposite and adjacent? You're like, oh, it's tangent. Very good. So we're going to write the tangent of 42 degrees equals to 8 over b. And then I would solve it the same exact way. I would get b is equal to 8 over tan 42 degrees, which is about, I don't know how much that is. So I'm going to go over here. I'm going to actually write over this function because I can. And so making sure that I'm in degree mode, which I am. So it's about 8.9 units. And then I put that over here. And I'm like, yeah, that looks like 8.9, right? I want to make sure that's true. Ways that you can verify your answer at this point is I would probably use the Pythagorean theorem just to make sure my answer is about right. So 8.9 squared plus 8 squared should be the same as about 12 squared. So is 143.21 close enough to 144? And you're like, yeah. So that's pretty good for me. I'm set with that. Let me make sure that I found all my angles and all my sides. I found 3 angles. I found 3 sides, so I'm good. So whenever you're looking for your, whenever we use these words, solve the triangle or find all unknown side lengths and measures, you're going to look for all 3 sides, all 3 angles, and then you're set. All right, so now I want you to take a look at number 9, and I want you to think, what tool will Miss Johnson use? Which tool will Miss Johnson use? First, I guess I should say. First. And so you say, okay, well, the 2 tools she told me were Pythagorean theorem and the trig ratios. And for this one, they gave me 2 sides. So all I'm missing is that 3rd side. So I'm going to use the Pythagorean theorem. So to start the Pythagorean theorem, I'm going to go leg squared plus leg squared equals hypotenuse squared. And if you're wondering why I do that instead of a squared plus b squared equals c squared, is because I've seen so many students just put whichever side they're missing in for c, and that's not correct. So I'm being a little bit more proactive here. So 7 is a leg, 20 is the hypotenuse. So 20 has to go in the hypotenuse spot. And then I'm just going to solve this. So this is 400 equals to 49 plus b squared. So b squared equals to, what is that, 351? And I don't think 351 is a perfect square, but I could be wrong. So let's see. Nope, it's not. Let's see. So I'm going to take the square root of this. If we were solving equations, my answer would be plus or minus the square root of 351. But because we're in triangle land, that's what we're going to do. And I'm going to simplify this. Let's see. 2 doesn't go into it. Let me try 3. It does. The 3's trick, by the way, if you want to know if a number goes into 3, is you add up the numbers. So 3 plus 5 plus 1, that's 9. And if 3 goes into 9, then 3 goes into this number. It's just a little, I've actually proven this before. So let me just take the square root of 351. And so I get 3 and 117. And then you try the 3's trick again, right? 1 plus 1 is 2 plus 7 is 9. So that's 3. And so that would be 39. And then this would be 3 and 13. And then I'm stuck. So that I'm looking for pairs. So the answer is 3 root 3 times 13, which is 39. So B is about 3 root 39. Just so you have an idea, it's about 18.7. So it's about, these are equals to 3 and about 18 point, what did I say? I forgot already. 18.7. And that looks like that makes sense to me, that if the hypotenuse is 20, one of the legs is 7, the other one is 18.7, that seems about right. So now normally you'd be done, and actually you would be done if you were in 8th grade. because that's when you learned how to do the Pythagorean theorem. But because you're not in 8th grade and you're in high school, now you have to actually use these sides to find your angle measurements, which is not something you could have done before learning about sine, cosine, and tangent. Sine, cosine, and tangent, those trig ratios actually bring together side lengths and angle measures so that you can actually find one or the other. All right, so again, Miss Johnson, training you to be whoever you're going to be. You always use the information that they gave you as opposed to information that you found. And I'm going to start with theta. So I'm looking at this angle here, and I noticed that they gave me my opposite and my hypotenuse. So I'm thinking about ka, to, and I'm looking for the one that they gave me opposite and hypotenuse. And yeah, if you said so, you're perfectly correct. So I'm going to go over here and write out my work. So it goes, the sine of theta, which I don't know, is equal to opposite, which is 7/20. And then now you should be asking yourself, okay, well, how do I get theta out of sine? And the way we get theta out of sine is if we take the inverse of both sides. So I am going to scoot this guy over and then take the sine inverse of both sides. Let's use this color. So sine inverse here, sine inverse here. And then the reason why we're using sine inverse is because that's how you undo sine. So now those two inverse each other. And then you don't say divide out or anything because they're not dividing. They're taking the sine inverse of the sine. You're undoing something that you just did, if that makes sense. Okay, so I'm left with theta equals to sine inverse of 7/20. I'm going to put them in parentheses because certain calculators, if you don't, it won't do what you actually want. So now I'm going to plug this into my calculator and figure out what the heck that is. So sine inverse looks like that on the calculator. And 7 divided by 20 is about 20.5 degrees. So theta is about 20.5 degrees. And so I'm going to squeeze that in here and say 20.5 degrees. And then the only thing that's left to find is beta. How would you find beta? Which tool are you going to use to find beta? And you're like, oh, the triangle sum theorem. And yes, you can use that. You can use beta to find the cosine of 7/20. That's fine. I'm going to actually use the triangle sum. So I'll go 180 minus 90 minus 20.5. And I got 69.5 degrees. So I'll write 69.5 degrees and then I'm done. Things that I would check maybe just to make sure is if I took the cosine of 69.5 degrees, I should get the same ratio as dividing 7 by 20. And it's not exactly the same, but it's really, really close, right? It's 20,000th off, if that makes sense. So we're okay. That's a pretty good margin of error for us right now. Okay, so the next problem I'm going to have you try on your own. Actually, the next two problems. So here's the next two problems. You're going to try on your own. You're going to solve these both. And then you're going to come back to me and tell me what you found. So both of these problems are completely doable. You can find all the pieces without even in exactly the same manner that we did here. And I even have kind of like a trick for this one. Okay. So go ahead and come back. And then if you don't know all of it, come back, watch the part that'll get you started, and then be on your way. Okay. So now that you're back, I'm just going to remind you, let's use let's use these rules over and over again, because these are going to help you. So just keep thinking about which tools am I going to use. So for this one here, because they gave me two sides, I'm going to use the Pythagorean theorem to find the third. So here's me finding the Pythagorean theorem to the third. Let's see. So I'd go 5 squared plus 12 squared equals c squared. And for those of you who've memorized your Pythagorean triples, you already know that c is equal to 13, right? So I'm going to show you that that's true. So this is 169 equals c squared. And then we take the square root of it, right? And then don't forget your plus or minus. So c equals 2 plus or minus 13. That's the correct answer for that equation. But because we're bringing it back into the context, we throw out our negative because right now for you guys, you don't have negative lengths of a triangle. You will later. Okay, that's a hint to your future. So, and then now I have to find angle A and angle B, which I don't know. So I'm going to start off with A. And I'm looking at what they gave me, and they gave me my opposite side and my adjacent side, right? And so you're thinking so ka to a, and you're like, which one gives me opposite and adjacent? You're like, oh, it's tangent, right? Some of you are getting better at this every single time. So I'm going to go with tangent of A, and I could just write that A like that. So tangent of A is 12 over 5. And then I ask, okay, well, how do I get A at a tangent? How do I get A at a tangent? How do I undo tangent? And you're like, oh, you take the tangent inverse of it. And that's exactly right. So I'm going to scoot this guy over to give me some room. And then I'm going to write tangent inverse here. Oops. I'm trying to do a different color. Let me go tangent inverse here. Tangent inverse here. You should know that these two undo each other because they're inverses of each other, just like adding and subtracting, multiplying and dividing. So therefore, A equals the tangent inverse of 12 over 5. And that just goes into my calculator exactly as the way you see it. So tangent inverse of 12 divided by 5, and I get 67.4. So A is about 67.4 degrees. And then I'm going to shove that in there. Let's see. Maybe I would like this. 67.4 degrees. All right. And then to find the other one, I'm just going to subtract him from 90. So 90 minus 67.4 degrees is 22.6 degrees. And therefore, I found my answer. And then the last thing I kind of want to do is just make sure that, I don't know, that 22.6 degrees really fits. So I would probably use sine. So I'll go sine of 22.6 degrees and then compare that to sine, which would be 5 over 13. I'm just checking my answer. I like checking my answer to make sure that I'm right. And so I got the exact same digits up until the 1,000th. And so I'm pretty satisfied with that. And so there goes my answers. Okay. So you should be coming up with like strategies. If they give me two sides, I'm going to be using Pythagorean theorem first. If they give me the opposite side in the hypotenuse, I'm going to be using sine in the sine inverse. Okay. A couple more problems here. These two here, it says 20, and then you can use the Pythagorean theorem here. This actually is a famous triangle that you will learn a lot about in a little bit. But you don't know about him yet, so I'm going to use the Pythagorean theorem. C squared, and so I got 400 plus 400 equals to c squared. So I got 800 equals to c squared. And when I square root him, I get 8 times 100. This is 10. So I'll leave the tens there. And this is 4 times 2, this is 2 times 2. So this is equal to 10 times 2, which is 20 root 2. And I'm throwing away that negative. So this is 20 root 2, which, by the way, I already knew because he's a famous triangle. Okay. And I'm going to show you a different way to do this one because this one's a special triangle. Okay. I'm sure you noticed that these two these two sides are congruent, which makes this an isosceles triangle. And we learned, I think last chapter, that in an isosceles triangle, the base angles are congruent. I think the way they actually say it is in a triangle, the angles opposite of two sides that are congruent are congruent. So in a triangle, the angles that are opposite of two sides that are congruent are congruent. Okay, so I know those are congruent. So then I think, okay, well, if I have 90 degrees left divided by 2, this has to be 45. Okay, and this guy is a famous triangle. I'm telling you, he's called the 45, 45, 90 triangle. Okay, we've talked a little bit about him, not enough about him to like be comfortable with him. But if you have the opportunity, start getting familiar with him to the point where you're like, ooh, that looks like a 45, 45, 90 triangle, right? Okay, the last one that I want to show you is this one. And this says, draw and find the missing angle measures of a right triangle whose side measures are 6, 8, and 10. Now here, what they did is they didn't give you a picture. So of course, the very first thing that I'm going to make you do is draw a picture, okay? And whenever Miss Johnson draws her right triangles, they don't quite look like right triangles, but because you know me, we're just going to make them. So 6, 8, and 10, I make sure that the longest side is the hypotenuse because that makes sense. And they now want me to find the angle measures. Okay. And so here you can't use the Pythagorean theorem because you already know all the sides. So I'm going to use sine, cosine, or tangent. And I'm going to label this guy as theta. And I'm going to find, and again, my favorite one is sine. So I'm going to go with sine theta equals 2. And I'm going to leave some space there. This is my opposite. So I'm going to go 6. Oops, I didn't leave enough room. I just said I was going to over 10, right? And then I ask you the famous question, how do you undo sine inverse? And you're like, oh, I said the answer. How do you get theta out of sine? And you say, oh, I have the sine inverse. Very good. Right. And so these will undo each other. And so I'm left with theta equals to sine inverse of 6 over 10. I like parentheses around these guys. And so that just goes on my calculator exactly as you see it here. So we go sine inverse of 6 over 10. And that's 36.9 degrees. So theta is about 30.9 degrees. So this guy's 36.9 degrees. And then I'm just going to do 90 minus to find the other one. And you could check your answers on your own. I'm pretty confident in my answers right now. Let's see. Yep. Let's see. Yay, my answers are right. Sorry, I was just thinking in my head of doing sine or cosine. Okay, so with that, that's where I'm going to leave this video and end it here because I think you have enough information. So the biggest thing that you were supposed to learn here was when you're solving a right triangle, you're going to be using your tools of Pythagorean theorem or trig to find out exactly what those answers are. Thank you so much for listening and go practice. Thank you.